Objective 6, use the discriminant to determine the number and types of solutions that exist eventually when you're going to solve a quadratic formula. So up until now, we've used a variety of different ways. We've solved by 3 different forms of factoring, we've solved by taking the square root, and then we've solved by the quadratic formula. Now we're going to just examine the discriminant that exists within the quadratic formula, and that helps us to predict how many solutions that we're going to have and what kind of solutions we're going to have. And so first, what is the discriminant? The discriminant exists here. And to put it into words, it is the number you get when you simplify what's underneath the radical. So, that just puts it into words. So please write that down. And it's listed then as b squared minus 4 times a times c. So whatever your a, b, and c are, when you put it into this part of the quadratic formula, that will give you a value. And this is equal to d, the discriminant. So d equals the discriminant. That's what we're trying to find, and that's what's going to tell us how many solutions and what types of solutions. So, for number 1, example 1 here, I'm going to go ahead and find the discriminant and then use the chart down here to discover how many types of solutions and what kinds they are. So again, it's the first step. The first 4 steps are just the same as what you do for the quadratic formula. So the first step is to put it into standard form. In order to do that, I need to have my quadratic equal 0. Right now, it does not equal 0. It equals negative 4 plus 8x. So I have to move both of those things. The negative 4 I can add, because subtraction and addition are opposites of each other. And if I add it to one side, I have to add it to the other side. And then the positive or plus 8x, I can subtract 8x from each side as well. So that cancels out on the right side. They both go away. And then to write it in standard form, it's the highest power all the way to the c term. So my 4x squared term, this is my highest power, minus 8x, the linear b term, and then plus 4 equals 0. That is my first step. Second step is to identify a, b, and c. A is 4, B is negative 8, C is also 4. My third step is to put that all into the quadratic formula. Or in this case, just because we're finding the discriminant, I don't need to put it in the quadratic formula. I just need to put it in this piece of the quadratic formula. So my b squared is negative 8. Again, I'm just putting it in this piece of the quadratic formula because that's going to tell me my discriminant, and that's this objective, to find the discriminant. So negative 8 squared minus 4 times a, which is 4, times c, which is also 4 in this case. And that will give me 0. So I have found then that my discriminant equals 0. That was this. Again, that's the discriminant, or the formula for discriminant. So I have found that my discriminant equals 0, and so after I do that, I'm going to look at this table down here. And just for reference, I found that d is 0, my discriminant. My discriminant is 0. So we have discovered this situation when d equals 0. And so to finalize this process, I need to include this piece of information in my answer. When d equals 0, like I found, then I will have one real rational root. And I know that this rational root is considered to be a double root, meaning that meaning that at that number, at that answer, it's going to bounce. So here's a graph of an example like x equals 5. It goes down to 5 and then bounces off there and comes back up. So it'll have a double root, means that it exists twice there. And again, the discriminant is not your final answer to solve this. I didn't solve my quadratic equation by finding the discriminant. Again, in order to solve it, I would have to continue using the quadratic formula. All I found is that I know now that when I do solve it, there's going to be one real rational root. A couple other situations that occur, if you get a discriminant that is greater than 0, and that is a perfect square. So let's say d is 64. I know that the square root of 64 is positive and negative 8. So this is going to give me two real rational roots when I continue to solve it. Another situation is d is greater than 0, but it's not a perfect square. So let's say d equals 50. The square root of 50 breaks down to plus or minus a simpler form of the square root of 50, which in this case is plus or minus 5 root 2. So at this point, I know that I have two real, but they're going to be irrational roots when I continue to solve right here. Because irrational meaning that it still has a radical. The radical didn't go away. And then finally, the last situation that occurs is when d is less than 0. So let's say d is negative 32. This means that I'm going to take the square root of a negative 32, which breaks down into plus or minus 4i times the radical of 2. So I know at this case that if d is negative, it's going to give me two complex roots. And at the very end, it's going to be a complex conjugate, which we're going to talk about in the next video as well. So as you're working through these example problems, the first thing you do is going to be putting them in standard form, and then you're just going to find the discriminant. So to find the discriminant, again, you're going to use b squared. The discriminant equals b squared minus 4 times ac. And once you get that, you're going to get a number, and then whatever number that is, you're going to reference back to this chart down here, and these are the situations that occur. I kind of wrote all over this now, but the first, the second, the third, and the fourth. So you have 4 situations that occur based off the number you get, and that will tell you how many solutions and what type of solutions. So your final answer when you're doing these problems needs to look like this, right here. The discriminant is 0, so I know that I have one real rational root, and that it's going to be a double root. That is an example of what your answer should look like, based on the 4 situations. So go ahead and try these 6 problems, and your goal for mastery should be 6 out of 6.